Okay, and where I left off yesterday, in that I have this in series to the L3 line of the run cap phase, so it's a vectored transformer in series coming off the run cap phase, and it's the L3 line, and it goes in the 9.9 ohm side, comes out the 3.5 ohm side, so it's kicked it down, and it's about 44 volts coming out of here. And I put it through a full wave bridge rectifier, and I connected it to the DC side of this other full wave bridge rectifier, and that has the two wires coming out of the flat disc alternator. This is AC, and I rectify that with this full wave bridge rectifier to DC. So I have the DC of this hooked to this, and then the DC, these so when I say this is hooked to the full wave bridge rectifier, the alternator output, that's going to the AC side, of course, of the full wave bridge. Now the DC side pumps into this battery over here, which is in parallel to this super cap bank of about 80 farads. So it is running, and you notice it's running off this inverter, which is running off the battery and the super cap. So it's in a loop mode now. It's running off an inverter that's powered by those, and this is pumping power into these as it's running this. So there it is. It seems to be growing quite a bit. Just using another meter. It doesn't sink very fast. And you know what? I don't trust anything. This is supposed to have... Oh, wow. That's not so bad. Here's what supposedly, this is the amperage being dumped into the cap and the battery. About an hour ago I had 190 milliamps, but that was just from this. So actually, now I'm in a little bit better mood. This made it, this really made a lot more amperage coming in to here and here in parallel. These are in parallel. So we got almost 400. It says 490 milliamps in AC, going from the bridge rectifier to the batteries and the cap in parallel. And there, I just saw this drop down. So it's not quite, because the battery and cap are not going up in voltage, very, very slowly going down. I can't say it's a self-sustaining loop. However, I do like this, somewhat successful. And I know that this will run a rotoverter motor at 420 milliamps and 12 volts. I wonder if I just let this go for a long time, that there'll be some voltage where it's going to, like 11.5 or even 11, like way down there. This can go to, I think, 10 volts. What's it say here? Input, yeah. I can go all the way down to 10 volts for this guy. I wonder if at 10 volts everything's going to work okay and last forever, because there's a big difference when you have a battery like at 10 volts and at 13 volts, and probably the same way with supercaps. So I can talk about it. But this is halfway successful, because, oh, here, I'll show you. If I take off what's coming out of the transformer, if I just disconnect the transformer, here's everything hooked up, disconnected. Yeah, see, look. This is with it disconnected. Without the transformer assist, the draw is now way up there. Now it's connected again, 49. So, okay, so this works. This works. What I could also do is, I'm going to turn this off. Turn it off. Okay, maybe I can put another transformer on it. I was experimenting with a series transformer from the actual power line to the L2 line. The drawing by Hector, he has a third transformer doing that. So, there we go. Okay, thanks for watching.